Alright, this is my third example of taking the curl of a vector field. So I want to find out if f is conservative, which just means is the curl of f equal to 0. So I need the curl of f, and this is kind of a difficult one, del cross f, because of this weird function here. So I'm going to start with the I hat components, and I do the partial with respect to y times the z component. Fortunately, there's no z component, so that's 0. Minus, then I do the partial with respect to z. Ooh, I wrote this out wrong. Of the y component. There is a y thing here, so we have negative 2x over y squared e to the 2x over y. Fortunately, there's no z's here. I'm going to correct this mistake before I move any further, because this should be dy. But dy of 0 is 0. There's no z in here anywhere, so this is 0. So the I part is equal to 0. The j part, j hat direction. Alright, so we start with the z part, d dz. Then we go to the I hat part of the function, or 2 over y times the stuff, because the y here canceled one of the y's in the denominator, e to the 2x over y, minus, I just did dz, and then the x part, so now I have to do dx, partial with respect to x, times the z part, and if there's no k hat component here, this is 0, and again, there's no z in any of this stuff, so this part is equal to 0, so that just means I need the k hat portion only to be equal to 0, and then the field is conservative. If not, it's not. So let's see. To do the k hat part, it's partial with respect to x times the j hat portion. So negative 2x over y squared with the e to the 2x over y. We will have to take that derivative, and also then we did dx times the y part. Now we have to do partial with respect to y times the I hat component, so 2y over y squared, which would just be 2 over y. I'll write that correctly. 2 over y. And then we have the e to the 2x over y. Alright, these, they do have the variables in there, so I'll need to take the derivative, and since it's in two different functions, I'm going to need to use the product rule. So just the k hat component, since this is equal to 0, this is equal to 0, I just need to worry about the k hat component. It's the partial with respect to x of this function, so using the product rule, first I take the partial of this one and write that. So I have negative 2 over y squared e to the 2x over y. Then I have the product rule portion of it. I do the other side. I take the derivative of this and leave this alone. So I'll write negative 2x over y squared times the derivative of this with the partial of this with respect to x. So I'm going to need to use the chain rule and get the 2 over y, and then write this down, e to x over y. Alright, and then I have minus this derivative here. So what do we have? Partial with respect to y of this function. So y goes down a power, and we put the coefficient out front. Negative 2 over y squared. That was the derivative of this first part. Then I have this stuff, e to the 2x over y. Then I use the product rule, and I have to do the derivative of this stuff and leave this alone. Let's see. Negative, or well, 2 over y. Derivative of this stuff using the chain rule is, since this goes down a power, it's negative 2x over y squared? Well, let me derivative of the second part. I write this down. This power goes down. It would be 2y to the negative 1, so it's taking the derivative of that is negative 2 over y squared. Yep. And it's the negative 1 makes this sign negative. Then I still have e to the 2x over y. Okay. Then I want to know if all this stuff is equal, so I'm going to check it term by term. The first term I have negative 2 over y squared, and I have a minus, and I have the exact same term here. So those two are the same, and then if this component cancels with this component, my field is conservative. So on top I have negative 4x. Over here I have negative 4x, y to the third on the bottom, y to the third on the bottom. My exponent is still the same, so this one cancels with this one, and my k hat is 0. So the curl of f is equal to 0. F is conservative. Thank you for watching, and let me know in the comments what you want to see next.